So quiet today. Just nobody's talking. Everybody's super focused on something. Everybody like tired, exhausted. All right. So I need some input from y'all. Okay. So I was in office hours, and I was just noticing a lot of students do seem to be behind on their work. Is that the case? Would you say so? All right. So as far as due dates, let me know. I can always adjust them as if needed. Okay. But if that's the case, I think then I'll give and rather than just doing what I had normally planned for today, I'll probably just go over dictionaries so that you have a better understanding of how to use them, because they are extremely powerful, but using them can be a bit subtle. Well, not too subtle, but you don't realize you need them until you actually find problems where you do. And then when you find them, the problems that you can use them for make them a lot easier. How are people doing on the Hurricane Tracker lab, by the way? See some, yes. Okay. Yes. Ooh. It's a fair assessment. So less exercises.
Yeah, I mean, I see the value of it. It's just I don't think I have enough time between the 4-class schedule and work. I don't have enough time to get everything done.
It's been a bit hard to calibrate, especially what that is, especially during the pandemic. And, also students, I need that kind of forthright kind of criticism. I'm not going to take offense to it, right? I'm not going to, but I can cut out some problems in the exercises if need be for Runestone. The Runestone, the purpose of that is to give you the chance to practice, to give you the chance to understand the stuff. I don't want to necessarily make it to become a stressful thing. That said, we aren't going to be continuing too much more past dictionaries in that book. After that, a lot of what you're going to be doing is, once we hit April, a lot of what you're going to be doing is, you won't really have too much homework other than the large project, which is self-directed, and it doesn't need to be a monstrously large project. Making a game or the like will satisfy just now. Fine. All right. So let me go ahead and just give you a couple pointers for the Hurricane Tracker. Okay. There's a couple of pointers for that. So I believe, well, that's a good question. What is the wind speed unit? I'll double check. So let's go down to the assignments and Hurricane Tracker. All right, so let's go ahead and download this. And I'll just download it to the desktop again. All right, so the wind speed is in miles per hour. There we go. So to figure out what category, by the way, what you want to do is just Google hurricane category. right? And that will give you the Saffir-Simpson scale. I always forget what it's called. You can go to Wikipedia just fine for that. And there it is in miles per hour for that third column. Now to open the file, so first off, what we're given here, right, is our folder with the files in it, which I will just simply move up there. There we go. Okay, so we've got our file. So we've got this folder and we want to read a file in this folder. So the way that we do that is over here, is that we open, as it was said, as Daniel said in chat, open data slash, because data is the name of the file in here. Sorry, data is the name of the folder right here. And then we want to open the file, and then we choose the file that we want to open. Okay, which would be, in this case, irma.csv. Okay. This is why it's important that you keep your folder, your structure, your folder structure the way it is. So let me go ahead and run this. And the fact that it popped up and went away is actually not bad. That actually meant it did everything it needed to do. It did all the turtle commands, which was exactly none of them. By the way, we've got this function over here called def irma setup. It creates the turtle and screen in the map background and a coordinate system set to match the longitude and latitude. It returns a tuple, which is like a list containing the turtle and the screen. It says don't change it. So you've got T, window, and map background image, which it returns. And we get that over here. So T is our turtle. We get window and map background image. We really don't need those. Now, if you want your screen to stop going away, when we are done, we just call turtle.done, not t.done, turtle. It's a function in the package that will, it will make sure, and now you can see that it stays up. Now I close it and now the program's done. So we'll make sure that it's not done before the turtle's done. Okay, now we've got the data. Now that we've got the data, reading the file is just as simple as making a for loop, right? For line in data, print, and this will confirm that we're actually reading the file. Print line. And you'll see in my output at the bottom that I've got a bunch of lines. And it's giving me a new line at the end because every line it's reading has a new line with it. So it gives me dates, time, latitude, longitude, wind speed, and pressure. So it gives me those details. And you'll see that that matches this file that we're reading. Right, here we go, scroll down to the end, and this is what we've got. Okay, so now the key is to split this line, which I'm not going to do because at that point I'm going to be doing the entire assignment for you, right? But at this point, what you want to do is that now that you've got the line, you want to read each line and split it into the data fields. Split it by commas, just like we did in the Pokemon in class kind of example I did, right? So you'll get index 0 will hold the day, index 1 is going to hold the time, and then you've got actually, what are these? Latitude and longitude, and then the wind pressure. Okay. Okay. Sorry, the wind and the pressure. So now what you're going to want to do is that you're going to want your turtle to move to the appropriate. So you're going to get this line, you're going to split it, and you're going to get your data. Now, each line is basically a chronological point. So basically, the turtle was here, then it moves here, then it moves here. How do you move the turtle to a specific point? What you're going to use is T for your turtle, because that's the turtle we got. And then the turtle has a specific function called go to, I believe. Okay, and that takes in an XY coordinate, and it will go to that XY coordinate. Okay, so obviously you want to feed it the latitude and longitude, or is it the longitude and latitude? Serious question. What is latitude and what is longitude, right? Let's go ahead and check that. This, by the way, I am pointing this out because when I try find an assignment like this that somebody else created, I always do it myself first. And this is a problem I spent multiple hours on. No, yes, maybe 45 minutes. I can't remember if it was 45 minutes or 2 hours. Latitude. Latitude is north-south. Right, specifies a north-south position on a point. Send me an email, but yes. Okay, send me an email, but yes. So latitude is north-south, whereas longitude gives us where we are. Let's see. Lines of longitude appear vertical with varying curvature. So these are the longitude lines. So you'll want to make sure you understand. So in other words, if you tell it to go to a longitude, a latitude, or a latitude, longitude, if that doesn't work, try flipping it, because you probably got your coordinates reversed. If you've got your coordinates reversed, your hurricane won't appear on screen. That's what I had that issue with mine. Once you've got your hurricane moving, at that point, you can start doing an if-else block to figure out what category it is. And then from there, it's done. Once you've got it working, it's really not that hard, believe it or not. This is one of those ones that looks complicated, has a couple moving parts, but it'll work. Okay. So with that, I'm going to introduce the tool that we're going to use for the next assignment, which is the dictionary. Okay. And we'll do it with some practicing, with some practice on file reading. Okay. So let's go ahead, and I'm going to go ahead and download, and I'm going to use Dracula again. So again, if you don't remember about how to do this, I'm just going to go to Project Gutenberg. I'm going to go to Project Gutenberg, search for Dracula. I'm already there, but I'm going to go through the motions. Search for Dracula, Bram Stoker. This will work for any text file, by the way. Actually, I'm not going to do Dracula. If I recall correctly, Dracula had an issue, so my bad. Let's go with Hamlet. Hamlet, the Prince of Denmark by William Shakespeare. Okay. So what I'm going to do is I'm going to click on this plain text file, and I'm going to save it, right? And this will work on any text file. You don't have to turn anything in today, by the way. You can just follow along at your leisure if you want to. So I'm just going to go ahead and save this as Hamlet.txt on my desktop. And I'm doing it on my desktop so you can physically see the file on my desktop. Oh, right. Let me give it its file name extension .txt. Okay. So, and here we go. I've got it over here. And let's go ahead and just to start to start this off, let's go ahead and I'll create a file called dictionary example.py, save it on my desktop. Doesn't matter what I call it. Okay, but we're going to start out by just opening up Hamlet like we have in the opening up Hamlet like I have in the past. By the way, my personal piece of advice, if you find yourself in need of extra humanities, just like to graduate or something, go and find a class on Shakespeare. Serious, no joke. And that's because that Shakespeare, despite being literature, is not meant to be read, it is meant to be watched. So Shakespeare then becomes mandatory movie watching, essentially. And it's quite good. The jokes lose a bit, they need a bit of translation because you're dealing with, you know, with a couple centuries of slang falling out of fashion, but it's quite good. And you have to realize that he also wrote for highbrow humor and for lowbrow humor. That's part of the reason why he had such a broad appeal. It's just the slang is a bit different. But overall, it's good stuff, and you'll recognize a lot of tropes. All right, so let's go ahead and open up Hamlet.txt, and we're going to read this file, right? So Hamlet and text is equal to open Hamlet.txt. Okay, and now, just going to confirm that I was able to open it. This will print out the fact that we have a wrapper, that we have a file IO kind of thingy here. Yep, says, hey, you've got this here. And now let's go ahead and just read this file line by line, 4-line in text. And this will take a while. Print, well, relatively speaking, print line. Okay, and now it's printing out, and it's done. Okay, so cool. So let's go ahead and just kind of work our way ourselves into a dead end. Okay, so I would like to know. So the most common letter in the English language is E. E is the most common letter in the English language. Okay. Now that doesn't mean that E is in every piece of text. There is a book without E. What is that called? Gadsby, a novel. It is a 1939 novel that Ernest Vincent Wright wrote. It does not contain any words that contain E in it, because apparently he wanted a challenge. So but for the most part, large corpuses of text follow a distribution. Relative frequency in the English language, right? So in texts, we'll see, and this ties into what we were looking at with the most common words, right? E appears about 13% of the time, right? 13% of all the letters are E, whereas less than 1% of them, less than 1/10 of a percent is Z. It's beaten out by Q, apparently. Although if you look at dictionaries, it does come up differently. But the point being is that every single language, and this is for the English language specifically, okay? For other languages, they have different fingerprints, but they do have these frequency fingerprints, which is useful for cryptography and kind of figuring out. So like, if you can recognize this pattern, you're like, oh, that's intelligible text. I can decode it now. Now, so with that, let's go ahead and start by counting how often the letter E appears in Hamlet. How many instances are there of the letter E? Okay, and before I do that, I do have to modify this text file slightly because it has the Gutenberg license on it, right? So So I'll remove this over here because I want to actually be able to get that. And then, right, they just simply have their header and tail because it's a public domain kind of work. Okay. And end of project. There we go. Okay. So now I'll create something called eCount, which is going to be the number of times I see the letter E. So for every line in the text, so let's go ahead, and what we're going to do is that I'm going to say line is equal to line dot lower, which will make it lowercase, right? Because there's capital E's and lowercase e's. I don't want to have to miss it just because somebody's name is capitalized like they are in plays sometimes, right? So line to lower, so that way I don't have to worry about capitals. Everything's now lowercase. Okay. So what I'm going to do now is, now that I'm going to say for letter, I can manually count it like this, for letter in line. If letter is E, E count plus equals 1, right? I'm actually going to keep it like this, where I'm just looking at one letter at a time, right? Okay. And let's go ahead and print. Okay. Print E count. So how many E's are in the text of Hamlet? There are 15,673 E's in Hamlet. Awesome. Now I want to see if that matches like our percentage. But this is of course compared to letters. So I have to filter out anything that's not a letter, right? So if letter is, so for letter in line, if letter, and let's go ahead and see. String, I think there's a useful string alphabet Python. Alphabet range. Yes, I could do it like that. Let's go, I'll go ahead and be not lazy though. If letter not in A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Did I miss any? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21, 22, 23, 24, 25, 26. So if the letter is not in there, I'm going to use a special super secret word called continue, which means, hey, go on to the next letter. Go on to the next thing in the loop. That's the same thing as basically saying, it's unnecessary though. I could just simply do it like this. If letter is one of those letters, if letter is in this one, total letters, total, and that's a variable I haven't created yet. I'll have to create pluralize the wrong thing. Total letters is equal to total letters plus 1, right? Just me saying plus equals 1. And so now we have to create that variable. 0, boom. Okay. So now we can print E count, and we can print E count divided by total letters. Okay. And we see that that made up about 11.6% of all the letters in that document. Right? So here's the thing though. If I want to get a count for each of these, doing it this way, I'd have to make like a letter for, I'd have to make a variable for every letter. Like, what if I wanted to find out what the average percentage was, or if I wanted to find out what the top three, you know, what the top three letters were? How would I figure out what the top three letters were? Well, the only way I realistically can do that, because I don't know what the frequency of text distribution in early modern English is. I can't, I mean, I should be able to assume, but it's bad. I should be able to assume that they are I, S, and E. Sorry, not I, S, and E. They are E, T, and A. Those are the most common letters. I should be able to assume, but that might be different in early modern English. That's what Shakespeare was writing. So the only way to realistically do that is to count each letter. But if I were to do that like I'm doing this, I have to create 26 variables with 26 if statements. It gets to be a real mess, right? Oh, and what if we're doing, what if I'm going even earlier? What if I'm dealing with earlier and I'm dealing with the thorn letter? One of the letters be removed from the English alphabet. It's the TH sound. So it's one of those that we just don't have anymore. Because reasons, I don't know. I'm not a linguist. I just know that that you know, letters have changed over time. And I mean, remember the fancy S's in the Declaration? Ones that look like. So could I iterate over a list of letters? Yeah, but I mean, like, I'd have to then, like, remember, if I created a list, I could kind of count them all with a list, right? I could say 0 is index, zeros are, the number at 0, index 0, that is representing the number of times I've seen A's. The index at 1, that is representing the number of times I've seen B's. 2 will represent C's, but that still means that I have to come up with a way of basically saying, oh, a big if statement, or I have to do some character math, which is ugly. So with that, so this is what we call a frequency count, where we're counting not just how often some one thing occurs, but how often all the things occurs, or a bunch of things occur. This is useful for counting the number of times words occur, the number of times email addresses occur, whatever. And this is one of those problems that dictionaries are good for. Dictionaries are good at three things: key value mapping, which basically is translating one thing to another thing, like a Roman numeral to a value. Counting, where you want to count a bunch of things, but you don't know what those things are, and categorization. Okay. So let's go ahead and boot up idle, just so we can have access to the talking to Python to kind of show you how the way a dictionary works. So a dictionary has a bunch of other names. It's also called an associative array, a hash table, a hash map. They're all words for the same thing. But they are the most abstract, they're basically the most abstract and powerful of all the data structures that you have access to. And we go over them in much more detail on how you build them from scratch in 2168. The way you do that, you create one, an empty one, is you say D is for dictionary, you can use whatever you want, is equal to, and rather than using brackets, you hold shift and you use the curly braces, which are pretty much never used unless you're in computer science. So we use those curly braces, and then we've got it, and see, it's an empty dictionary. All right, so the idea here is that it operates in Python a heck of a lot like a list, except you can make up whatever index you want. I can say at index 5, well, it's not an index in the dictionary. We call this a key. So at key 5, I want to store the value apple. And at key 165, I'll store banana. And if I print it out, it says 5 gives you apple and 165 is banana. Okay. And what it's done is that it's created an association, a pairing, a mapping between a key and a value. So if I go ahead and say, ask for 5, it's going to give me back apple. It's like a code. If I go ahead and say D 165, it's going to give me banana. And if I say D some other number, it's going to tell me key error because I didn't create a mapping. Okay. Just like an index error, if you get an index that, if you try to go to an index that does not exist, you get an index error. Here you get a key error. However, the power in dictionaries isn't that you can just simply set up the numbers, whatever you want. I can do something like this. D, favorite fruit is equal to blackberry. I really like blackberries. And now we see that we have a mapping from 5 to apple. 165 would give me banana, and favorite fruit would give me blackberry. Okay, so if I say D, and it's going to be the string because I gave it a string. Favorite fruit is going to give me blackberry back. Now it doesn't work in reverse. If I put in D of apple, it says you don't have a key called apple, right? So the thing on the left is the key, and it gives you the value, which is on the right. Does that make sense to everybody? Now we can put whatever we want for keys and whatever we want for values for most parts. Typically, they'll be either numbers or they'll be strings. Now you can iterate over these but let's figure out what those are. For thing in D. What in the world am I going to print out? What print out thing? And I honestly can't remember because I work in multiple languages. And it will print out the keys. So for thing in D, print out, it'll give you the keys. So you can iterate through it and it'll give you the keys. And as a result, if I wanted to print out the keys, the key and value pairs, I could say for key in dictionary, print key and D of the key. So that would give me the key and the value. 5 apple, 165 banana, favorite fruit, blackberry. Have I lost anybody here? It creates a pairing. It creates a pairing between two things. So again, these work just like indexes, except you get to make up what they are. Okay. Can we use the index key to find blackberry, or is it different? The key, well, we iterated over 5, 165, and favorite fruit. Favorite fruit, the key favorite fruit gives you blackberry. So if I wanted to change something, let's go ahead and just create a new dictionary right over here. D is equal to a new, so D is going to be equal to a new dictionary, so that clears everything out. D, I'm going to go ahead and just use single digit numbers now. 0 is equal to, sorry. We'll go ahead and say first is equal to apple, D, second is equal to banana. Okay, so D. So now now here's one of the things that you gotta see. So if I do D of first, and I change it to the worst fruit ever, which is a durian. First off, it's a failing of Python that it doesn't just reject durian outright because durians are terrible. But anyway, so if I reuse a key, right? I've reused the key first and I said, hey, store durian in the key for first. Create a key value pairing from first to durian. It replaced what was there, right? Just like how you would replace what was an index, right? So you can update anything with anything else. Also, there's nothing that stops me from basically changing it back again. First is equal to back to Apple. And then there's nothing that stops me from also saying that another variable has the same value. Another key can have, two keys can have the same value. But two values cannot have the same key. It doesn't work that way. We're only making keys. So how in the world does this apply to our problem, the problem we were working on? The way this applies to that problem is that we will create a pairing for each of our values. There we go. What we're going to do is that we'll create a dictionary that will have basically a pairing for each of the letters. Right? And so on and so forth. Right? We're going to create a pairing for each of the letters, where the key is the letter and the value is the number of times I've seen that letter. Does that make sense? The key is the letter, the value is the number of times I've seen that letter. So each time, every time I see an A, I'll take the number of times I've seen an A and add 1 to it. Right? Once I see a C, if I see a C, I'll take the number of times I've seen a C. And I'll say, hey, instead of storing 0, you should store 1. Once I see another C, I'll say, hey, instead of storing 1, you should store 2. Make sense? That way we can keep counting all these things. So we're going to do this for letters, and then I'm going to show you that we can do this for words as well. So let's go into here. So for line in text, let's see. And we'll just comment out these things over here. We don't need them right now. And we don't need these variables anymore. So for line in text, and instead, I will just simply I'll create a count. Equal to a new dictionary. And now you may notice that I did not populate it with any letters. That's okay. I could, but I could. Let's go ahead and actually start it that way, and then I'll go ahead and make it a bit more. Then I'll make it a bit more advanced, so where we don't have to do that. Okay, so I'm going to go ahead and populate this. So for letter in each of these, I'm going to say the count of that letter, right, is going to be equal to 0. So if we print the count, I know, then this feels like jumping forward from this might feel, I know this may feel like going from going from walking to rocket powered roller skates, but the only thing that's really changed that made this more complicated is the for loop and the fact that we've got a variable. All I'm doing is I'm iterating through this and saying the key A gets the value 0, the key B gets the value 0, the key C gets the value 0. They all get the value 0. Invalid syntax. Where is my invalid syntax? Letter is not defined. Or letter in, A line is not defined. Because print count. Where is my line not defined? There we go. Just wasn't running it. Okay, there we go. And so you see my dictionary, I've got A, B, C, D, E, F, G, H, I, J, K, L, M, N, P. All of them have all these letters have been initialized to 0. Sorry, have a key representing the letter and a value representing the number of times I've seen that letter. And so now what I can do is I'll take this, I will move it down here. Okay, and now what I'll do is, so 4-line in text, 4-letter in line, if it's one of those letters, right, then what I'm going to do is I will say, hey, if that's a letter, give me the amount of times I've seen it. Times seen is equal to, and I'm doing this in more lines than I need to, just because it's easier to read, count of that letter. So this retrieves the number of times I've seen that letter, okay? Like if I've seen E 5 times, and E is the letter here, this will be 5, and 5 will be stored in times seen. And then I'll say, hey, now that the number of times I've seen that letter should be equal to times seen, it's the value that's currently in there, plus 1, right? Make sense? Or I can just simply shorten that to saying, hey, plus equals 1, right? But I'll just keep it here right now. So if it's a letter, get the number of times I've seen the letter, increment it. Why does it keep? Okay. And there we go. We've got the same count for E, which is 15,000. Okay. And then A appears 10,000 and change. T appears 12,000 and change. Right? So this allows us to count all the letters. Yes. Mm-hmm. Time seen is an integer because it's a variable that just got created here. I'm asking, give me the value associated with the key, with this key. Give me the value that's associated with this letter. Give me the number of times I have seen this letter. Okay. Does that?
So my issue, I think, has been letter in ABC letter. It's just returning that letter, not mine.
Did you Is it there or later? Because I did comment this part out.
Hold on. Yeah.
No worries. So 4-line in text. So, but a lot of times when we're counting something, we don't necessarily know what we're counting or how often we're counting it. So normally we don't even have the chance to initialize this. Does that make sense? Yes. Oh, let's see. A is 0. I think it just got glommed together. Give me a second. There, yeah, it just got glommed together with the previous output. Yeah, so this is the output for this. All right. Any questions before I move on? Any more questions, I should say. So what if we don't want to or can't initialize what we're looking for? That's not too bad. What we do over here in that case is that we set up an if-else statement. We say, hey, if letter in count. In other words, I'm asking if this is a key in the dictionary, right? Let's go ahead and see how that works. If first in D, sorry, actually, no, not if, just first, just because it's not an if statement. First in D, that gives me true, right? Because first is a key in this dictionary. Apple in D, it returns false because apple is not a key in the dictionary. It's a value, right? It's a value in the dictionary. We only really remember keys here are the first class citizens. They get to, it's basically what the dictionary cares about. So here we're saying if the letter is something I've seen, if I have a key of that letter, and we're just doing what I did earlier, which is just simply, so all we have to do now is if, so I'm just retyping the line I just deleted, if letter in count, right? If I've seen it before, get the number of times I've seen it. Add 1 to it. And store it in there. Otherwise, I haven't seen it before, but I've seen it now. So the number of times I've seen the letter is equal to 1. Make sense? So if I haven't seen it before, add 1 to the number of times I've seen it. Otherwise, add it to the dictionary. I've now seen it once. Make sense? And now if I run this, actually, we get a very different result. I had A, B, C, D. Well, or rather, we get a result presented differently. It's actually the same result. We get T, H, and then E, and then R, and then A as our dictionary. Now, why does this happen? Because it cares about which ones were added first. So if you look, the tragedy of Hamlet, T-H-E-T, tragedy, R-A, right? It went in alphabetical, it went in the order it saw it. So it's presenting the keys in the order which you inserted them into the dictionary. It's really all it cares about. Order in a dictionary doesn't really exist strictly. It's only usefully enforced there. But anyway, now we have a count of all of the letters and how often they occur. What about words? How could I figure out how often get a count of all the words that occur? I'll go ahead and comment this out and start from kind of the beginning here. Count. So now let's start at the beginning. And so we've got our text and we create a dictionary for counting our words. Okay. So here our goal is to count up what is the most common word in the tragedy of Prince Hamlet. Yes.
So I was doing, like I was following along and I forgot to put in the letter C part and I got the same result.
The letter seen?
Like that line, with line 13, I didn't have it and I got the same result.
Interesting. Just without that?
Yeah.
You can do it just with like this.
Yeah.
That's perfectly fine.
That's what I.
Yeah, that's fine.
Is it the same?
Yes, it is. I just broke it out so that it would be easier to read.
Oh, okay.
Or at least I thought that was pedagogically better, but I don't know.
Oh, I was kind of confused. I didn't really understand.
Oh, this is just getting the number of times I've seen it. So I've seen this letter, get the number of times I've seen it before, and now add 1 to it and store it in letter. Remember, because when you do this, when you're doing this, count letter plus equals 1, when you're doing that, remember, that's just a shortcut. That's literally just this. Remember, plus equals is just simply a shorthand. It gets expanded. It's literally just
You just reassign count letters.
I just reassigned it so that it would be so that I would break it up. I wanted to make sure that basically to understand that you could retrieve these values from a dictionary as well. So let's go ahead and look at how we do this for words instead of on we're going to try this on words rather than on letters, because we can't populate all the words. We'd have to go through the entire dictionary, and that's its own ordeal. So for line in text, now what we're going to do is we are going to take that line and we want to split it. All right. And typically what separates one line from another. Okay. Typically what's going to separate one line from any other line is a space. So line, or sorry, what separates any one word. What separates one word from any other word is a space, right? Last space, night space, of space, all. And then there's some random punctuation. Yes.
How would you separate the comma? And wouldn't the word be returned all comma?
Yes, that's a problem for later me. Right? Right now I just want to split them up. Right? I want to split up I just want to split up I'll deal with anything that's not a letter later. But for right now, I want to split up by spaces so I can just individually deal with them. Okay. So, and there's a couple ways I can do that. I can do that, just via brute force, essentially. So let's see. Dictionary examples. So text is equal to text.split. And we're going to split on the string, just on a space. Okay. So and then from here, we're going to say for word in line. And if I do this all, it's going to just, take forever, of course. So, but I'll go ahead and print them and you can see that. Oh, right. No, that's not good because I was not printing out every line. I was printing out every word. I was printing out the line each for every word. So it was to print line here, just temporarily past this so that we skip that. And there's all the words, and we can see and then we have some weird gibberish and stuff. Okay. But actually it's not too bad because we already have this. So I'm going to be very kind of clever / also brutish about this with using some while loops. Okay. So what I'm going to do, so we can see that we split it up into words, although we do still have like stuff with commas and stuff. Speak loudly. All right, we'll figure out how that works. So here's what I'm going to do, I feel. So first off, word is equal to word dot, and then I think strip is one function we can look at. So let's go ahead and look at the string strip function. Even without this, I'm still planning on doing some things. Strip string Python, which should bring up. Why does it always come up with W3 schools as opposed to just the dictionary or just the documentation? A string, common string operations, Control F, strip. Does it not have it? Could have sworn. Common string operations. Oh, I'm not in the right file. String methods, see here. Here we go. Strip. So strip dot not. Seriously, what's going on here? Find index alpha is space L strip. R strip. Split. Strip. There we go. Returns a copy of the strings with the leading and trailing characters removed. The cars argument is a string specifying the set of characters to be removed. If omitted or none, it just defaults to removing white space. So spacious, see how it's got leading and trailing white spaces. With strip, we'll remove all the white space. Okay. Similarly, the outermost and leading trailing characters are the ones stripped here. So notice that if you've got this string where we've got pound dot 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 dot, and then we've got this over here, and we're saying strip all this stuff. It recognizes, hey, when I hit characters that I don't want to strip, don't strip into between those. It's actually pretty clever. So we can actually use that. So first, yeah, let's go ahead and use that. We don't need to be we don't need to be, we don't have to code this up ourselves. We can just use strip. So what I'm going to do is I'm going to first turn it into a lowercase word, word.lower. And now word is equal to word dot strip. And what I'm going to do is I'm going to strip out, let's see, how did it work in the documentation? Yep, just a string of all the things you want to strip from it. So period, comma, question mark, exclamation point, bracket, underscore, close bracket, parentheses, I guess, and space. And then we'll print the word, I guess. And we'll do this for, let's see, text is equal to text dot read lines. That way I can only, and the reason I'm doing this over here is so that I can specify the starting and end points. I only want to do this for the first 100 lines. Because otherwise, so there. That's just a weird apostrophe. We've got some blanks over here, some empty spaces. Things that are null. Basically where there were empty lines, essentially, in the input file. So we will so there, we've cleaned up our word. So, and then let's go ahead and make sure we're not adding anything that's like empty. So if word, so now we can add it to our dictionary. So if length of word is greater than 0, in other words, if this isn't an empty string, right? Then we can add it to our dictionary because it's actually a word. And this over here is Hamlets. It's just encoded differently with a weird apostrophe, right? You've noticed that in one of your assignments where basically that this single quote is not an apostrophe, right? It's not. It's not the same, even though we use it as the same. There's a different character combination. So if the length of the word is greater than 0, what are we going to do? We are going to say, hey, if word not in count, I'm going to reverse it this time. If we've not seen this word before, then I'm going to say the number of times I've seen it is equal to 1. Else, the number of times I've seen it should be incremented by 1, right? If I've not seen it before, add 1. If I have seen it before, add more than 1 to it. Okay. And now what we'll do over here is I will move this so that it goes over the entire text. And let's go ahead and print the count. And run it, and right. So over here, we've got a count of all the words. Oh, looks like I didn't remove the new lines. Okay, so that's easy enough to do. I'm gonna do two separate strips because I know that this one will work. This one will remove white space. Word is equal to word.strip. When you don't provide any arguments for strip, it will just work on white space. And so 2 successive operations should work. So there we go. So so the appeared once. Now this is a weird like beginning of the file character. That's why that one is there. And notice that it is the first thing that got added. It got added before the tragedy of William Shakespeare. It's like probably right here. So if I deleted this, let's see, I deleted that, run it, let's see what happened. And nope. Yep, it's just saying that's the beginning of the file. So that's what's going on there. Okay, so we've got that now. So yeah, I've got a dictionary. Now the question is, how do I figure out what the most common word in the dictionary is? All right, how in the world do I like this? Because I've got this by value. And this is possibly one of the most common things you want to do with the dictionary. And despite that, I have to look it up every time if I want to do it in a short way, which is like, how do I sort a dictionary? Either like by key or by value, right? And then print it out. And typically so sort dictionary by value. So you can see the autocomplete. Sort dictionary by value, Python. Sort dictionary by key, Python. How do I sort a dictionary by value? And see on Stack Overflow, it is very common question. And the answer is basically you can do, somebody says, hey, do this weird dictionary comprehension thing, which I find less than satisfactory because I don't really like having to tell you, hey, use magic that you don't understand. Because that's what this is over here, some magic over here. I understand it. It says key lambda is equal to x. So sort dictionary by value. So sorted. Aha. So let's see. I saw an answer. I just want to know if there's an easier way to do it. Okay. So, and the way it's saying to do that is, let's see, print sorted. Let's see. And sorted D items. So count items, but that's just going to give me the sorted keys. Items. So that just gives me the keys. C gives me in an alphabetical order. You can see here. So let's see. For key in sorted. All right, key is equal to, okay. Sorted D, so sorted count. Sorted gives you something, you give it something, it gives you whatever it is sorted back. So, and then key, in other words, how do I want to sort it? Should be count. Should be what? That tells me how I want to sort it. By default, I want to sort it by this. Sorry, by default, it will sort it by the key. Well, that won't help me because that's right. There we go. Key is equal to count dot get item. This is a bit of magic, but basically what this is, it's a much shorter magic and less esoteric. What I'm saying is here, taking the count, and the way I want you to sort it is by using the get item functionality in it. In other words, I want you to sort it by values. I want you to sort it by the items that are stored in it, not by the keys. Key in this case is a different context. This key is different from this key, which is kind of confusing. So let's call it K. Let's call it for words stored in this, the sorting keys. Yes, print word. Count of that word. Okay. Stop. And now run this. And now we're printing it out, and now we'll see that. So there we go. So the appeared 1,114 times in the file. The and appeared 981 times, 735 times too. So we can see that each of these words occurred a lot of times. Polonius occurs 120 times in the Hamlet. So this is something that I have to look up every time. It's not something I expect you to remember. It's just such a common task that looking it up is kind of just something you'll do a lot, where you're saying, hey, I want to sort this. If I didn't have this, by the way it would work, sorted just automatically sorts something for you, by the way. Again, if I didn't have that, then the way it sorts it is by the key. And if you notice, it is sorted alphabetically now. And again, this is apostrophes over here. And here, again, these are apostrophes. Twas, apostrophe twas. All right. So dictionaries are, again, really powerful tools for doing this kind of thing. In your homework assignment, which is Hawaiian pronunciation, the way you're going to want to use dictionaries is to translate, is basically to say, hey, this letter, this letter or this pairs of letters will make this sound. So in other words, it becomes an easy way for you to translate without having to make 1.5 million if-else blocks. You can do it with if-else blocks instead and completely forgo to use dictionaries. Dictionaries are not required to do anything, but they are an extremely powerful tool that make them work. What would happen if I did sorted count word? Well, it really wouldn't. Word doesn't really exist there. I think I get a syntax error. Let's see. Yeah, key error. You get an error there because it's saying word doesn't currently exist. And I think, yeah. Yeah, it's a key error because you can't access that like that because word is still left over from here. Oof. Okay. But all right, so it is 3:11. So let's just talk about what we're going to do next week. Next week on Tuesday, I'll do the in-class exercise on Roman numerals, which uses dictionaries. We'll do that in class as an in-class exercise. And then on Thursday next week, we will start what I find to be a very fun portion of the thing, because we're going to talk about Monte Carlo approximations. We're going to talk about new bar game scams is one thing I really like to talk about. We're going to talk about scams and games that are scams a lot. Specifically, we're going to, so Monte Carlo will be, you know, a couple worth of lecture, but they're going to be fun lectures because the idea behind Monte Carlo is that math and statistics can be hard, but counting the outcomes are easy. So let's just count how often people win or lose. For those, you'll notice that I don't have lecture videos so much as I do have YouTube videos of other things, which are all Monte Carlo approximation related. All right, so class is dismissed for the day.